the Department of Animal. I would like to thank the organizers for giving me the opportunity to present this large-scale initiative currently ongoing under the Food from Thought program. Along with my co-investigators, Professors Elijah Chiari, Alexandra Harlander, and Tina Widuski, we opted to combine our expertise to find solutions in order to enhance the health and welfare of laying hens in the context of a high egg production. Over the last 60 years, intensive genetic selection for egg production has resulted in tremendous improvement in egg output per hen. As highlighted in the figure, the red line corresponding to an unselected strain of white leghorns, whereas the green line corresponds to a strain of the 2000 and the blue line a current commercial line, we can see that gains were made by reducing the age at first egg, increasing the peak production, which now reaches 100%, extending the duration of that peak production, as well as increasing the length of a laying cycle. As a matter of fact, modern layers are expected to lay in excess of 500 eggs by 100 weeks of age. So as we can see in that graph, between the red and the blue line, the egg output has been more than double. That also means that the investment from that hen into egg production has also proportionally doubled, meaning more nutrients diverted to egg production, more calcium used for eggshell formation. This did not come as a bigger bird. As a matter of fact, this selection program resulted in more efficient birds able to better partition their energy. Simultaneously, the industry is also undergoing a transition. Driven by welfare concerns and consumer demand, in Canada, conventional cages are currently being phased out in favor of enriched colony system as well as aviary system. It is now well established that such systems are much better for the welfare of birds. However, they may come with some potential health issues. For example, it has been shown that the use of aviary system results in higher risk of keelbone injury due to the utilizations of a three-dimensional space and elevated structures. As well as we've seen, birds have been selected for the last 60 years solely on their production parameter. And are those birds actually ready for the transition? All of those issues were identified and captured in the latest code of practice for the care and handling of pullets. As part of this, several questions have been raised. Should pullets be reared in the same environment as their future housing? And if they are not, does that impact the utilization of the space, especially elevated structures? As well, different environments correspond to different requirements, as the energy expenditures will differ greatly between a cage and an aviary system. However, no real recommendation on nutrition exists, and should the nutrition be adjusted depending on the housing system? And how would that impact the production and the health? For example, the integrity of the musculoskeletal system. As a result, our focus is really on growth and skeletal integrity. Growth during the pullet stage and transition from the pullet to the adult stage, leading to the lay of the first egg. If we look at the level of the musculoskeletal system, well, in terms of skeleton, the growth will occur mostly during the early stage of the pullet. This is also where those bones will start accumulating materials. And as sexual maturation occurs, the switch in bone physiology means that instead of structural bone, the calcium will be packed in the medullary part of the bone and will be utilized later on to sustain that egg production. As we can see, calcium becomes a very important part of that pullet stage to ensure the animal will have sufficient amount of reserves to sustain those 500 plus eggs. As well, beyond the growth of the skeleton itself, the load bearing and level of activity of the bird will impact the development and the health of that frame. In addition to that, as we just mentioned, the transition from a pullet to an adult layer here means we're switching physiology from growth to reproduction. Thus, our team combined those expertise. Myself, Gregoy Bedecarrats, focusing on the physiology with a lot of emphasis on growth and body composition and how that body composition impact the sexual maturation and later on the lay of eggs in adults. Professor Chiari, a poultry nutritionist, focuses on the dietary calcium. Can we improve the amount of calcium that is stored during the development of the pullet before the transition? And should we adjust the type of calcium in the diet? At the level of the activity, Professor Alexandra Harlander, a poultry behaviorist, is focusing on the utilizations of elevated structure, the use of flight muscles and flight feathers, and how that impacts the development of the musculoskeletal system. Whereas Professor Widusky from the poultry welfare team focuses more on the environment and the impact of the rearing environment on behavioral and skeletal development. The whole intent behind the Food from Thought program was to group those expertise, to combine those expertise to drive innovation. As individual researchers, we all had ongoing research, we all have ongoing projects and individual projects that are supported through our common ways of doing so. Through commodity groups, including Egg Farmers of Canada, Egg Farmers of Ontario, CPRC, and others, as well as private companies that can be feed mills, feed companies, or ingredient. Those individual funding are then matched with funds from federal programs, including NSERC Alliance, as well as the Agriculture, Agri-Food Canada clusters. And on our side, we'll also have privileged access to our research facility in agreement with the Ontario Ministry of Agriculture. Now, all of those individual projects, to really put them together for a concerted solutions, were all packaged together as part of the Food from Thought program, coming from the Canada First Research Excellence Fund. This was the perfect opportunity here to really tackle these issues in an efficient manner. So to date, after 5 years running through the Food from Thought program, one of the key metrics or key output has definitely been the training of HQP, with more than 5 postdocs, 6 PhDs, 10 masters, and countless undergraduate students. Now, as part of that, the fact that we all work together on that common goal has led to a significant increase in the interaction between students as well as between co-investigators, which included sharing space, sharing animals, as we aim to answer similar questions, and as well share analytical techniques, share samples, so that really drove the innovation. Now, in terms of communication and outreach, so far, over 8 peer-reviewed publications have come out, 20 conference abstracts, 7 invited presentations, and 9 media public appearances. So again, showing that that combined approach really helped drive output. Now, in terms of collaborations, as I mentioned, we really enhance our internal collaborations, but beyond our own group, having that multi-pronged approach really help us even collaborate further beyond the chicken worlds. So you may ask, with all that collaboration, has there been any breakthroughs? Well, here I will list a couple of examples, and specifically some of them will be presented by students and postdocs as part of this session. On the physiology side, I would say one of the earliest and biggest breakthrough was to show that, in fact, metabolic status and body weight or body composition can control reproduction. And as a matter of fact, there seemed to be a body composition threshold that will then allow the hen to mature sexually regardless of its age and regardless of the photoperiod. Now, it seems, however, in our latest study that will be presented by Mohamed Bari, here that threshold, in fact, is not set across the board and depends on the strains, brown versus white feathered bird, and as well the growth trajectory. Now, in addition to that, and that will be highlighted by Dr. Charlene Hanlon, who finished her PhD last year in my group, that the laying persistency is linked to a cyclical recurrent elevation in estradiol, and those elevations in estradiol are also associated with recurrent waves of follicular recruitment, and something we did not observe in unselected birds. So I will strongly recommend or suggest you follow the presentations of Dr. Hanlon and Mohamed Bari. On the nutrition side, as I mentioned, Dr. Chiari focused more so on the calcium requirement. And one of the key findings that came from his group that, in fact, the limestone particle size, its effect depends on bone type and age, with fine particle increasing mineral density in the femur at 16 weeks, whereas coarser particle reduce the incidence of keel bone damage and keel bone fracture later on at 24 but not 40 weeks. Again, highlighting here that as the bird grows, the digestive capability and the use of calcium will differ. On the behavior sides, utilizations of elevated structures were shown to depend on strain, with white birds more prone to use elevated structures rather than brown. As well, the wing feathers, the flight feathers is critical here for developing the flight ability. And in fact, clipping those feathers will reduce the flight ability and increase the leg muscle thickness as the bird uses more of its leg. Now, as well, losing the flight ability severely impact the utilizations of elevated structure. Those data are also presented today by Ms. Renee Garan. And on the welfare side, our results show that the importance of exercise and the design of aviary system for the health of the musculoskeletal system by impacting the load bearing on the skeleton. And again, we can find all of the details here in the presentation by Ms. Anna Wrench. So what's next? The impact of feather damage on the integrity of the musculoskeletal system will be instrumental to implement new design of housing system. On the nutrition side, we are well overdue for an update of the NRC recommendation. And as part of this update, again, the type of environment should be taken into consideration. On the physiology side, we are now trying to identify the specific mediators that mediate that metabolic status onto the reproductive axis, and more so using full body scan using DEXA. And I encourage you to look at Ms. Sierra Shaw's presentation, where she'll be presenting her master's proposal. Having said that, just a little bit over time, and I am open for questions.